This is a review sheet of 8.6.8.8, Simplifying Radicals, Pythagorean Theorem, and the distance formula. So section number 1 up here, we're just going to be simplifying each square root or radical into simplest radical form. So trying to split each one of these numbers into pieces, we're going to factor them out and try and find a perfect square. So just a reminder, those numbers we're looking for are 4, because that's 2 times 2, and 9, because that's 3 times 3. Oh, we can't see that. 16, 4 times 4, 25, 36, 6 times 6, 49. Once we get higher than that, it gets a little more difficult, but we could keep going, right? 64, 81, 100. All of those have actual square roots. So if I took the square root of 4, it's 2. The square root of 9 is 3. The square root of 16 is 4. The square root of 25 is 5. So we're trying to split these into pieces. So when I look at square root of 18, if I can factor this and split it into two pieces that are being multiplied together to make 18, I could pick 6 and 3, but I don't find either one of those in this list. So while you can break it up into 6 and 3, it doesn't help you get this into simplified form. But I do know that 9 fits in. So I'm going to split this into 9 times 2. And then the reason that helps me is because the square root of 9 is 3. So I know square root of 4 equals 2, square root of 9 equals 3, 4, 5, 6. So these will lose the square roots and just become the whole numbers. So square root of 9 just becomes 3, because 3 times 3 is 9. And square root of 2 stays. Can't do anything with it, so final answer is 3 radical 2. Okay, number 2. This one I see right away I can take a 25 out of. And if you divide this by 25, you'll see it goes in 5 times. The square root of 25 is 5, so the square root of 25 becomes 5. Radical 5 just has to stay because there's not a nice whole number square root for 5. Square root of 36 is just 6. Square root of 20 is not a perfect number, so we're looking for one of these numbers that fits in perfectly. No need to look at the numbers that are bigger than 20. They're not going to fit into 20. So we're just looking at 4, 9, and 16. Out of those 3, 4 is the only one that's going to fit in. So I can factor out a 4. It's 4 times 5. So I've split 20 into 2 radicals. And square root of 4 becomes the whole number 2. Square root of 5 just tags along. 72, you got a couple options actually. 9 is going to fit in. But there's even a bigger number that fits in, and it's 36. We talked earlier, if you watched some of the earlier homework videos, and we actually looked at this specific question, that you want to find the largest perfect square that goes in. Otherwise, you're going to have to do some extra steps, and I'll show you that here once again. So 36 times 2 is 72. Square root of 36 becomes 6, and square root of 2 stays. Now you might have said square root of 9 times the square root of 8, and you wouldn't be incorrect. This becomes 3 square root of 8. But this is not complete because my square root here, the 8, I can put a 4 into that. So I'm going to leave the 3, split the 8 into a 4 and a 2. The 4 now, square root of 4, becomes a whole number 2. All of this is multiplication. So this is 3 times 2 times the square root of 2. 3 times 2 gives you the 6 out front, and the square root of 2 sits right there. So you're never actually done simplifying these until the radical that you're sitting here with cannot be split into any of these perfect square roots. So I want to show you that these are all equivalent. So if I take the square root of 72 and just get the decimal answer, there it is. If I take 6 square root of 2, you can see it's equivalent, it's the same answer. And if I even went with a 3 square root of 8, it's the same number. So these are all equivalent, but what is the simplified form? It's 6 radical 2. So this is halfway there. always got to make sure you get down there completely. Again, the trick is you can get there in one shot if you pick the largest perfect square, but always double check yourself. So radical 8, we just did it right here. It's going to split into radical 4, radical 2. Square root of 4 becomes 2. Square root of 2 tags along. Square root of 80. At first you might say, I don't think any of those fit in. So what you need to do is you need to start dividing it by different numbers. We should know that 4, first of all, is going to fit in. So if you wanted to use 4 to start off, you could. There are going to be some bigger numbers, though, that fit in. But let's start with 4, because that's probably what you saw. So if you saw 4, you know 4 times 20 is 80. And so square root of 4 splits to 2, and you have 2 radical 20. If you look up here, radical 20 can be simplified. So we would then have to split 20 into 4 and 5. The 2 would sit out front still. This 4 becomes a whole number 2, gets multiplied with this one. And so we have 4 from the 2 times 2, and we're still left with radical 5. So a faster way to get here at this one is if you recognized that 80 can be divided by 16. And you recognize that just by trying it and seeing if you get a whole number. And it goes in 5 times. So you could have started off with radical 16, radical 5. Square root of 16 is 4, and it gets you right to your final answer. All right, so if you can find the bigger square root, it makes your life easier. 75 is pretty simple. We're going to put 25 into it 3 times. Square root of 25 is 5. 108, I would just start trying stuff. Let's try 36. 108 divided by 36. And it works. So 36 times 3 is 108. So I'm going to split this into 36 and 3. Square root of 36 is 6. And I'm left with square root of 3. I'd go to 25 here. And if you're not sure, just do the division. 150 divided by 25. 6. Square root of 25 is 5. And 6, when you first look at it, you might go, can I go farther with 6? But if you take a look, is 4 going to fit into 6 evenly? No. 9 is already too big. So 6 is simplified. Final answer 5, radical 6. All right. Now down here, you technically could find the actual points, the coordinates, the x and the y, from the endpoint to the other endpoint and use your distance formula, but the directions here specifically want us to practice Pythagorean theorem. So what we're going to do is we're going to complete the triangles here. And we've talked about that when they follow the grid, you can actually just count boxes to see what's the size of this. But if it's diagonal, you can't. And so that's why we have to use the Pythagorean theorem. We can't just count over how many boxes this is. If you visualize this swinging up to this line, if you said, well, how come it's not just 1, 2, 3, 4, 5, 6? How come it's not just 6? If I swung this up, if you can visualize it, it's not going to swing up and hit right here, which would be 6. This is going to be longer than that. Okay, so diagonally, you can't just count boxes. But for these, the up and down, we can. So this one is going to go up 1, 2 boxes. So this length here is 2. This one, 1, 2, 3, 4, 5, 6. So the base of this is 6. You could also look at the numbers. We're going from -4 to 2. That's 6 spots. We're going from 0 to 2. That's 2 spots. So Pythagorean theorem. The most important part is our C. We've got to get that C correct. And I saw some of your homework earlier in the week. Some of you weren't getting the C right. You find your 90. Whatever's diagonal from your 90, that's your C. So that's our missing piece. That's what I'm looking for in this particular problem. And because all of these we're looking for the diagonal is going to be your C. And so these are all going to kind of look the same. But the two sides coming out from the 90 that actually touch the little box, when you make that 90-degree angle, those are your legs. Those are your A and your B. Does not matter the order that you put them. So you could do 2 squared plus 6 squared, or you could do 6 squared plus 2 squared. It doesn't matter. We're going to have 4 when we square 2, and we're going to have 36. Combine them, you get 40. Now that would make sense if this is 40, right? We should just be able to look at that. If this is 2 and this is 6, that's not 40, because this is our x, and 40 is x squared. So whatever x is, if I multiply it by itself, I get 40. So algebraically, to solve this equation, I need to take the square root of both sides. When I take the square root of x squared, it's x. And the square root of 40, if you try it in your calculator, which you can always do first if you want to, but if you think about it, we know that these are our only perfect squares, and 40 is not on there. So 40 is going to give us a decimal. Okay, so what that means is, unless the directions say give your answer rounded to the nearest whatever, which ours don't, then a decimal version is no good. And so our answer would be the square root of 40 if it couldn't be simplified, but we're going to leave our answers in simplified radical form, which is what we just practiced up top. So we need to split 40 into some pieces. We should see that 4 is going to go into it. So square root of 4, square root of 10, square root of 4 is 2. So my final answer is 2 radical 10. That is a good answer in simplified radical form. Okay, question 2. Let's complete the triangle. You can go either way. Actually, it doesn't matter. So if you want to draw the triangle up this way, you can, and here's your 90. You could also draw it here and here. The sides are still going to be the same. This length's going to match this one, and this one's going to match this one. So that doesn't matter. I'm going from -4 to +2. That's 6 spots. 1, 2, 3, 4, 5, 6. Going from here, I'm going from -3 to 5. That's 8 spots. 1, 2, 3, 4, 5, 6, 7, 8. Color the boxes if it helps. So I'm going to plug directly in to Pythagorean Theorem. My missing side over here is my hypotenuse. It's diagonal from the 90 degrees. That's my x. So my legs, the two sides coming out from the 90, my A and my B, are the 8 and the 6. So 8 squared plus 6 squared equals x squared. I don't want you to get in the bad habit of just taking whatever two numbers you see and plugging it in for A and B. For these particular style of questions, that is what's going to happen. But if I just gave you a random triangle, which you will see on the quiz, and I told you that this out here was, say, 100, and this over here was 40, and this was x, if you were going to set this one up, my legs are right here. So you would say 40 squared plus x squared equals 100 squared, because that's the hypotenuse. That's my C. Okay, so we can't get in the bad habit of just taking any numbers we see and plugging it in for A and for B, because that's not how it's always going to be. Find your C across from your 90, your hypotenuse. Okay, plug that in, and then A and B can go in either spot. So we get 64 plus 36 when we square them. Put them together, that's 100. Square root both sides. And when we do that, 100 has a nice answer of 10, and we are done. 1, 2, 3, 4, 5, 6. I went from -3 to +3, 6 spots. 1, 2, 3. 3 boxes up. I went from -2 to +1. That's 3 spots. So these are my legs, my A and my B. So when I plug into this formula, I'm looking, where's my C? That's the important one. That's what I'm solving for. That's my X. So these two numbers can go in here in either spot. Oops, squared. So 3 squared is 9. 36. Put those together, we've got 45. And I have to square root both sides to get rid of the x squared. I want to know what's x. I don't care what x squared is right now. Split this into pieces. Looking at your perfect squares, 9 does go into this, so it's 9 and 5. The reason we do that is because the square root of 9 is a nice number. It's 3. Square root of 5 is not a nice number, and so it stays 3 radical 5. All right, this side is 1, 2, 3. This side is 1, 2, 3. So when I plug in, those are my legs because they're coming out from my 90. My missing spot out here is my hypotenuse across from the 90. So it's 3 squared plus 3 squared equals x squared. That's 9 plus 9 equals x squared. So it's 18. Don't care what x squared is. I need x, which means I need to take the square root of both sides. That creates x. Square root of 18 can be split into a 9 and a 2. I do that because I know the square root of 9 is 3. Square root of 2 just stays, and 3 radical 2 is my final answer. Okay, to the back now, using our distance formula. Distance equals square root of the entire quantity, x2 minus x1 squared plus y2 minus y1 squared. Doesn't matter which one you call x1 and y1. I'm always going to go from left to right just to be consistent, but you could go from right to left. If you do it for the x, you got to do it for the y. So subtracting your x's in here, I'm going to go from here to here. Inside parentheses, it's negative 10 minus negative 10. For my y's, I'm going to go the same direction. You have to be consistent. So 14 minus negative 6. Both of these will go plus, plus. So negative 10 plus 10 is 0. And in here, I'm going to get 20. So 0 squared is just 0. 20 squared is 400. So combined, I get 400, and that's still all under the square root. So my distance equals the square root of 400. What number times itself gets us 400? Well, we just did it right here. It's 20. So you would take the square root of 400, and you get 20. Just a quick reminder, if you're working at home without a fancy calculator, grab your phone, find your calculator function. Okay, you would just turn it sideways to get your extra scientific functions. Here's my square root of 400, and there it is, 20. Just a reminder too, there is a cube root function on most of these phone calculators. For me, I don't have an iPhone, so I'm not sure if the iPhone calculator is exactly like this, but I know for me, I just hit this, and there's my cubed root right there, and I could hit that and go from there. But we're not doing any cubed root on Pythagorean Theorem or distance formula, but just know that it's there. Okay, plugging in here, I'm going to go directly into the formula now. This was our answer. So I'm going to do x minus x, so 2 minus 10 squared plus y minus y, 13 minus negative 2 squared. 2 minus 10 is negative 8 squared. That will become a positive. Any negative squared is a positive, so that's 64. This goes plus plus, that's 15 squared. I know that's 225. You can plug that in though. 225 plus 64 is 289. So distance equals the square root of 289. First thing you should do and check and see, is there an actual square root of 289 as a nice number? And there is. Square root of 289 is 17. 17 times 17 is 289. So our final answer is a nice whole number. If you don't get a decimal at that point, since we're leaving our answers in simplest radical form, not as a decimal, you would have to split 289 into pieces, but we don't have to because it has a nice whole number square root. All right. X minus x, negative 7 minus 5. Y minus y, negative 1 minus negative 10. So negative 7 minus 5 is negative 12. Squared will be a positive 144. This goes plus plus. So this is 9 squared. So this is 81. 144 plus 81 is 225. So my distance equals the square root of 225. Go ahead and try that and see if it comes out to a nice number. Square root of 225 is 15. 15 times 15 is 225. Number 12. X minus x is negative 5 minus 3. Y minus y is 8 minus 2. So I get negative 8, which will become a positive square when I square it, 64. 8 minus 2 is 6. So 6 squared is 36. Put those together, that's 100. So the distance equals the square root of 100. What number times itself gives us 100? It's a nice, even whole number 10. X minus x, negative 2 minus negative 12. Y minus y, 10 minus 5. So right here I'm going to go plus plus. Negative 2 plus 12 is 10. Squared is 100. 10 minus 5 is 5. Squared is 25. So I'm going to get 125. Now, if you take the square root of 125, you get a decimal. So because the directions did not say round your answer, it says give your answer in simplified radical form. We need to go ahead and simplify this radical. So we're going to split this into pieces. Hopefully, we have to find one that has a nice square root, and 25 would be the answer. So 25 fits into it. We know that will become a 5. And 25 times 5 is what gives me the 125. Radical 5 does not have a nice square root, so we're going to leave it, and final answer is 5 radical 5. Last one. X minus x, negative 14 minus negative 12. Y minus y, negative 7 minus negative 1. So this goes plus plus. That's going to be negative 2 squared. Any negative squared becomes a positive. 2 times 2 is 4. This goes plus plus. That's negative 6. Negative 6 squared, positive. Negative 6 times negative 6. 36. So everything underneath my square root is 40. So my answer is the square root of 40. We've already done this one here today. Square root of 40 is not a nice number. So we need to split it. 4 goes into this for sure. So I can split it into 4 and 10 because 4 times 10 is 40. And I chose that because 4 has a nice square root of 2. 10 does not have any numbers that fit into it with a nice square root. And so my final answer here is 2 radical 10.